Hi, I'm Ella Atkins. I'm going to give a brief presentation that goes in with the Good Citizens of Robotics Research workshop on fostering diversity of thought. I want to kick things off by just giving a bit of background in what legacy we have to build from, which is really important and really useful as we do research in robotics. First of all, physics. How many of us have really pulled in a lot of the principles of mechanics, electromagnetism, et cetera, into what we do in robotics? Calculus is so fundamental in K through 12. As soon as we can reach past algebra, we learn calculus and then discover the wonderful things it can teach us about physics. Chemistry. Those of us in robotics have used a lot of batteries, a lot of silicon chips, a lot of different materials that are very strong and lightweight. So these things, we tend to be users of the principles of physics, the components that we build in chemistry, and those legacies are so important to us. And most of us aren't really trying to build a better material or come up with a better quantum physics, relativity, et cetera, type of principle. But we do rely on these concepts, and we sometimes take for granted that maybe calculus does everything and that it's the basis of everything, whereas calculus really in its legacy was intended to give us better descriptions for things like the physical laws of electromagnetism and mechanics. Moving on to the right, artificial intelligence. Over the past 50 years, we've tried to mature the notion of artificial intelligence. We started out with strong and weak, where strong was emulating human thought, weak was doing some sort of skill that a human might be able to do as an expert system. Here we are in the year 2020, and we still don't necessarily know exactly what artificial intelligence is, but we have a lot of different legacy principles. There are a lot of people right now that use deep neural networks to do what I'll call function approximation, but they do it really well. And in the end, when you're writing a proposal or asking for funding, you tend to say that anything that you can is AI. Well, this legacy has mixed results because maybe it helps you get money, but is it really AI? Well, we're not sure, because maybe if it's function approximation, we wouldn't think of it as AI any more than the thermostat in your house is AI. So where does that legacy leave us? Well, we really want to have explainability. We want to have models that are based on data structures that somehow represent the equivalent of language that humans have. So there's a lot of different questions in how to move forward, and sometimes assumptions hold, sometimes they don't. That's true in most of the principles where we define models, data structures based on foundations that are abstract as opposed to immutable, such as gravity. So now the last thing on this slide, law and regulations. One of the things that legacy gives us is a combined experience that lead to things like the Electronic Code of Federal Regulations of the United States. In my world of aerospace, the Code of Federal Regulations has a lot of implications for things like aviation. What do pilots need to know? What do aircraft need to be able to do? How are they safe? In software, we're still trying to figure that out because we still have challenges with things like adaptive systems. So then we have the gaps that we see in things like transportation. If we look at the federal regulations gap, legacy tells us in aviation that we have to have deterministic, correct statements for everything that's safety critical, yet that gives us a certain rigidity that we try to plug the gap in with pilots. With other forms of transportation like cars, we never had that legacy of certification. So now we're boldly going out and deploying systems that may not actually be 100% or even close to correct. What's right? Well, we're getting there faster with the autonomous cars because we're allowing litigation to serve the purpose of certification processes that are well established. That lets us go faster, but at the same time, we have more risk being passed along to the drivers when, say, buggy software and systems that really don't always perceive accurately or make correct decisions are deployed. Finally, with the case law, right? Everything has legacy and precedent that we build upon in our legal systems. A question as we have new technology that we try to push is, do we want to adopt existing regulations, existing law, and push that as hard as we can without changing it? Or do we want to adapt, to make new laws, to make new regulations, new certification processes? We probably want some combination, but there are trade-offs because adoption tends to be lower cost and less controversial. Adaptation tends to have more risk, but also allow new things to happen. In transportation, you see cars and planes on this slide, and this has a bit of a human-centric element to it because the legacies really matured because of what people needed, what people wanted in their transportation systems. If you look at the upper left, this is a reminder of what the original dashboard looked like. The dashboard really was this piece of material, leather, wood, whatever, that was put on a wagon to prevent mud and so forth to fly back onto the passengers. There were no electronics, there were no instruments, there was no controls. It was just a mechanical or a piece of material. So then if we evolve toward maybe 1980s to early 2000s vehicles, we find that the dashboard has become quite different. It's a place that we have instruments that tell drivers what's going on with their car. In this particular case, the person must be driving pretty fast because the speedometer says a little over 100, so we'll ignore that for now. That's not my car. And then more recently, we have computers that are taking over the displays so that we can get a host of map and other diagnostic information about the vehicle. So we have to adapt to all these different ones. And what happens next? Well, right now, we're pretty comfortable with the legacy. The human sits in the front seat and there's a steering wheel on one side or the other with pedals on the floor. As we have autonomous cars, it's less clear whether the person will have a cell phone with some kind of user interface to communicate with the car, use natural language, some combination. But those things are gradually evolving. On the right, you see a legacy of aviation. The upper left picture is a DC-3 vacuum-based cockpit. It looks pretty complicated, but nothing's computerized. It's all analog instrumentation that the pilot and the co-pilot would look at. In the middle, you see a modern glass cockpit, fly-by-wire system. You still have crew members that are redundant, one, the pilot on the left, co-pilot on the right. But now, instead of having these old Scott-style instruments and mechanical controls, you have keyboards, joysticks, and a lot of computer screens. If we look at unmanned aviation, suddenly things have changed. This is an example control room for a large unmanned aircraft, where a lot of people are required just to fly one aircraft more than in a single commercial transport aircraft, because a lot of them are looking at data feeds from all of the sensors, as well as managing the mission. Here on the right, you see air traffic control. The old legacy was you had a person looking at radar trying to understand what was going on with traffic and weather. Now we have a combination of people looking out screens at runways and also looking at a variety of different feeds of computer systems, providing things ranging from radar with air traffic to a lot of annotated information about flight plans. So if you ask the questions, how do we drive? We have a certain legacy description of how we drive, and when we advance systems, we usually have the drivers really turn the wheel and push the pedals as if everything was mechanically connected, even though we have drive-by-wire, and later we have systems that will override the drivers if they make mistakes. In how do we fly, there's the assumption that it's a human-centered system, both on the ground managing the traffic and in the aircraft, or on the ground managing the single aircraft with computers taking data links. So then in the future, we need to break down any assumptions that we've made right now based on legacy. when we come up with new technologies that are better. So for example, with aviation, there's a real question of whether voice should be carried forward. Perhaps instead, data link, which can be redundant, resilient, secure, all of the words that you need to have safety critical information, use that data link, will actually avoid a lot of accidents relative to today where voice tends to be ambiguous and slow. So if you look at the technologies and the history of how they came about, you find a lot of diversity in thought, whether it's with science, computer science, engineering, or any of the other fields, including law, that have given us the foundations of what we do with robotics, computer science, engineering, and other fields. One of the things I want to point out, though, since this is a notion of being good citizens, is when we teach introductory subjects, we often tend to bring in scientific laws that have names associated with them. Newton's law. We see Euler, Lagrange, many of the famous scientists and mathematicians that have given us some of the foundational laws that we have to go on in terms of science. Interestingly enough, if you go to this Wikipedia page and you look through the list, you'll begin to think that perhaps all science was done by white European males, which is not quite accurate. And in fact, if you look at popularity surveys, you'll find that people like Marie Curie were very popular, not just because people liked her, but because she did really important work in chemistry. But if you look at these scientific laws, you'll find that even when you find Curie there, Curie's law, it's named for Pierre, not Marie. So what does this mean? Well, I'll get back to this a little bit later, but it really calls to question what we're teaching when we teach history alongside science, and how we make sure that people who are hearing about this history understand that it was a different time, that it wasn't a matter of these people who did these things being uniquely qualified because of their genetic traits. Anyway, that was a bit of an aside, but being good citizens, we have to think deeply not only about our craft, our science, but also about being good citizens and making sure we're inclusive for everyone. Being inclusive in terms of getting past legacy, accepting new ideas as being potentially exciting, leads to two big questions. First, it seems to always be the case that when you get that paper out there, when you get that proposal finally into the big funding agency, almost always, people seem more excited by extensions on familiar concepts than they are by things that are out there, that are truly novel, but perhaps extreme or irrelevant, or an island that doesn't seem to be well connected. And that can be a problem. So in fact, in the limiting case, some proposal calls seem to ask people to repeat back what it is that the agency wants, as opposed to someone thinking creatively and putting in their best idea of what they want to build their career on as a researcher. So in terms of getting past legacy, celebrating the new, we have to think carefully about how do we celebrate rather than penalizing new problem formulations, new approaches to problem solving, and new applications. Even though we might be a little more comfortable with legacy. And when we are reviewers, we also have to give people the benefit of the doubt, even if they're not studying exactly what we're familiar with. The second question, how do we notice and deal with schemas which lead to bias? So this is for people and for places. I'm going to focus on the people side of it, but anytime you want to take that shortcut to make sure that you have time to do everything because you're oversubscribed, we all are, that can lead to bias. All right, so how do we celebrate new problems? Well, here's a couple of slides maybe giving advice. Some of you may know this better than I do, but here goes. I've faced this for a while. If we want to really define and study a new problem, then we need to connect it with legacy. Don't deny the literature. It's very, very rare that your new problem is truly an island disconnected. You want to explain why the new problem is different, give illustrations, show give us a vision of what's in your mind with this new problem, but don't deny the literature. Work really hard to connect it. And also, maybe this is a little cynical, the next piece of advice is to feed our egocentric biases. What I mean by that is connect the new problem to old problems so that there is an excitement underlying this new problem that says, hey, if I solve this new problem, it's going to help us gain insight into these other problems that already existed or help us solve them later. There's nothing more exciting for someone who's reviewing a paper or a proposal than to see how it's going to affect them in a positive way. What about new approaches? Well, I think the advice here is very similar. We still want to connect with legacy, find the most comparable approaches, and if possible, benchmark, benchmark, benchmark. We have to be able to find some cases of problems that existing methods could already solve, and then show how the new approach solves them, and numerically quantify with established metrics, possibly new metrics, but don't forget the established ones, how well your method works. In this case, feeding the egocentric biases translates to explaining how your new method builds on existing methods from the literature, and also being honest in how the new approach works not quite as well or even equally well to existing approaches. It's very rare that a new approach works best all the time. If it does, great, that will show up in the metrics. And if it's not universally applicable or doesn't work quite as well in some cases, don't hide them. Bring them out, make them clear, because at that point, the community can use your method as well as possible. So the final piece of advice in this day and age where things are so easy to share, if you have code, share it on GitHub. If you have methods and results, make sure you detail them enough in your publications that they can be reproduced. All of us like new approaches better if they're easy to access, easy to use, easy to understand. In terms of new applications, such as a new vehicle that doesn't look like others, that gets us from point A to point B, a new design of robot that might do better with assembly or manipulating some complex structure or working with a natural environment in a new way. Visualize, help us understand what the system or the architecture is going to do with a schematic, with a sketch, artist's rendition, early results if you've done some tests in a lab, and then connect the new application with things that already exist. Again, connect with what we want, what we crave as researchers. Help us understand how we're going to become more productive, happy, wealthy, whatever. Make it clear that the new application augments the big box of tools that we already have, the big box of applications that we can draw from already, so that we can understand how it connects to the legacy, even though it is not the same. And now that second question, what are schemas? Well, schemas are expectations, and the next few slides, you'll see this STRIDE University of Michigan Advance icon at the bottom part of the slide. One of the things we do is have the professors, the grad students, staff have this series of workshops called STRIDE, which helps us think at least as carefully as each of us can about schemas and biases and how we can be aware of our own tendencies to have them. So schemas are stereotypes that allow us to very quickly classify perhaps inaccurately information. You can see at the bottom of this slide, there's the assumption that boys have trucks, girls have dolls, and that's not really a fair assumption because people are individuals and can have many different preferences in how the objects they like, the things that they think, the things that they do. There's this implicit bias test or implicit association test that if you have time, I encourage you to take this implicit.harvard.edu exam. It's not like a real test. I think it's a little more fun to really explore what your own individual schemas might be. So once you have schemas, we're all busy. We all try not to discriminate, but no matter who we are, we usually bring some kind of unconscious bias to our situations, which results in us perceiving and treating people differently. And so that means that we have to understand how to overcome these biases to improve our decision making. Why do we use schemas? We're busy, we're high stressed, we're stressed out, we have lots of time pressure. We don't have a complete set of information, so we tend to need to make assumptions about things that are not observable, things that no one has told us about, people or places or things. So another thing is if we see an individual, like is shown in this group of birds, we might not think highly of it because it didn't fit in. There's not quite as much critical mass. There's a lot of literature in this. You can see at the bottom of each of these slides, there's several references. If any of you want any more information on these references, please feel free to email me. My email address is on the first slide. So what are some examples? Well, when you're evaluating same gender job applicants, one way of classifying each individual is as a parent or a non-parent. So you have mother, non-mother on the female side, father, non-father on the male side. Statistically significantly, mothers were rated as less competent, less committed, less likely to be recommended, and offered lower salaries than non-mothers. The opposite happened with fathers. The fathers were rated as more committed and offered higher salaries than non-fathers, just because of that gender difference. So all of us have been subject to letters of recommendation as we've gone from students to professionals post-graduation. And as we grow older, we spend more time writing letters of recommendation for others than actually receiving them. So there's not really any way of getting around it, at least right now, because so many jobs require it in grad schools, et cetera. What are the pros of it? It allows us to get at the individual. We're not judging the individual by a number like a GRE or an SAT score or a GPA. We're using verbiage, text, to understand what that person is like, usually based on someone who really thinks highly of that person. What are their strengths? What have been their roles? What kind of accomplishments have they had that don't fit on a curriculum vitae very easily? The problem is that the letter writers often write quickly because they don't have a lot of time to write each individual letter. And so they're not quite as conscious of how the biases that they may unconsciously have go into those letters. They can put irrelevant information and potentially harmful information. Also, sometimes people allow the candidates to write the letters themselves, and it's not really a letter of recommendation from someone else. Nonetheless, if you study letters of recommendation as large batches, that's illustrated by this envelope with a letter falling out of it, you find that women have shorter letters. Men have more standout adjectives like outstanding and excellent. Women are more meticulous, hardworking in terms of the description. With men, there's more professional references to publications, patients if you're in the medical field, colleagues, and so on. Whereas the women have more doubt raisers in their letters, like she is close to my wife. There are similar challenges when you compare letters for white versus black applicants for jobs. The white applicants tend to have more standout adjectives, again, the outstanding, excellent, and so on, where the black applicants tend to have more mere competence adjectives that are less strong. So here are some examples that have been compiled at the University of Michigan that show examples for the different terms that are being used on that last slide. Let me just read a couple of them. As a hedge, one of the 3 Indian ladies we have here this year, she is perhaps the best. I meant of the 3 Indian ladies, but this is not really a strong statement because you should be comparing this candidate to everybody, not just the 3 Indian ladies. And then there's maybe the most severe one here is the irrelevancies, the recommendation letter that says an Afghan American and a practicing Muslim woman who wears a veil covering her head but not face. This doesn't belong in a recommendation letter. That's purely an appearance. It's not a professional trait. And then maybe the faint praise one I'll read last. My overall impression is that when she is motivated, she brings enormous talent and energy and is very productive. But that's not really strong praise, because what happens when she is not motivated? Presumably that's not a positive thing. If you go from the letters of recommendations into things like teaching evaluations, you also find challenges. So in this particular slide, there were lecturers that were given the same script in front of similar bodies of students. And in one set of lectures, the male instructor referred to his partner as Jennifer and the other as Jason. And the presumably straight instructor got more positive comments, and the gay instructor got 5 times as many critical comments, which really suggested that that was playing a role in the evaluations. This is not the only study that's been done. Again, many references are present where it's been viewed that, or observed that members of minority groups often are viewed as less credible. Here's an example. I'm not going to read it, but I encourage you to look through these slides later. It's quite often that African American faculty, both male and female, have barriers with respect to proving their qualifications and authority in the classroom. And these quotes from 2 professors say that in terms of the bottom one. The first thing is to set the tone in the first class session that you're in charge. Don't ever let that slip, because the moment you do, because you're a person of color, you will never regain that. So that's very challenging. I mean, a lot of people who look like they should be a professor, and when I say look, I mean the stereotype, the schema look, the you could have a science law written after you and named after you kind of thing. So let's get back to that, revisiting the scientific laws by name. If we dwell on this history, then maybe we're not being good citizens, because we need to make sure that we celebrate not just 17th, 18th, 19th, and early 20th century science, but the future of science. The future of science has diverse ideas, diverse people that are creating those ideas, and as good citizens, we need to make sure that we invite all of those ideas and respect them and interact with each other in a positive way to get them across. Finally, novelty can be low-hanging fruit. If you find something that just was waiting to be solved, sometimes that can give you a lot of momentum, a lot of opportunities to work with students, to work with colleagues, so that you can really get something running fast. You always should look for the novelty. Never become too comfortable and get settled in what you're doing. There's always an exciting problem out there if you look for it. You know, from my experiences, I have to put this in. Sometimes people will steal your ideas despite your efforts to put things on archive and GitHub or whatever. This is bad, but this was the best advice I had when I first became a young faculty and had one of these situations. If you had one idea, you'll have more. And that's what having an exciting career, going to conferences like RSS and having discussions is all about. I look forward to speaking with you at the workshop.